students. This time we are going to look at composite function. What does that mean? Basically, composite function, or sometimes it is called composition of function, is just you have two or more functions and you just have to do it one by one, continuing from one to the next one. So basically you are going to have a certain value here in the beginning, and then you apply function f and get the image of that value, and then you continue with the function g. So the notation for it, if you actually think of working with f first and then continued by g, then you will put f behind. So that will be the notation for it, of a composition of function. Or sometimes you also write it this way. So you have fx inside, and then outside you have function g. They mean exactly the same thing. So at the moment maybe it doesn't mean anything to you, but we are going to look at a concrete example of this. So for instance, here I have two functions. Function f has a rule 2 times x plus 5, and function g has a rule x minus 3. So let's say if I start with the domain of function f, just keep it simple. I have 1, 2, 3, 4 here in the domain of function f. So I will try now to find, okay, what will be the result in the end. So I start from 1 here, and if I apply function f to 1, so meaning I need to try and find the image of 1 with the rule of function f, I will substitute 1 into x here in the rule of function f. So 2 times 1, which is 2, and then add 5. So we will have 2 plus 5, which is 7. And then afterwards, I'm going to use this number 7, and I will try and use this in function g. So I will substitute 7 into the x value into the x in the formula of function g. So then I will have 7 minus 3, and the result is 4. So this process you can just right away try and write that. Who is the image of 1 after this composition of function f and g? So the end result is 4. To say so, then you can write it this way. For instance, I am going to write it as f1. So the principle is that you will do the inside function first. So in this case, substituting 1 into the x of function f, then you get 7, and then afterwards then you apply function g, so which means 7 minus 3, and the result is 4. So this notation means you are finding something that goes right away from 1 right away to the end result, and that's the meaning of composition of function. You may also write it, as I said before, some other notation for it is g, and then with a little circle here, f1 is equal to 4. That's another notation for it. So remember, the one which is inside is to be done first, and in this case the one nearer to the x value is to be done first. Sometimes they put also bracket here, but not to worry, it means exactly the same thing. So let's see if you can actually understand this, and let's try another example. So we did with 1 already, so let's try. If I want to start with 2 and I write down something like this, oh, can you find me the composition function of f and g? And if I want to know what the result is here right away, if I start with 2, what will be this number here? So of course you need this stepping stone. First, you are going to think, okay, who is the image of 2 according to the rule of function f? So let's check. The image of 2 according to the rule of function f. So x is 2. If I substitute it here, then I will have 2 times 2, which is 4. Add 5. So 4 add 5 is 9. And then afterwards, I'm going to think, okay, if it is now 9, if I apply function g, so I put 9 into the x position here of function g in the formula, then I will have 9 subtract 3, so 9 minus 3 is 6. So then it means the final result after doing this composition of the two functions f and then g, then the image of 2 will be 6. Or again, I could also write it this way, and it just means exactly the same thing. Image of 2 after the composition of function of f and g is 6. So very simple. Now, sometimes I might not want to do this one by one using numbers. I might just want to find a formula that goes right away. Can I find a new formula that goes right away from the first set to the third and the last one here? Will I be able to combine somehow these two formulas and find a new formula that will give me a rule that goes straight from the first set to the third set? Well, of course it's possible. It's the same thing. So then if I want to find that formula, I'm going to write it this way. That's the notation, either with bracket or with the little circle. So I am going to find now. So you see here, it's not a number. I'm not substituting any number for x in specific. I just want to find a new formula using x. If I substitute any number here on the first set, what should be a formula that will bring me right away to the final result? So the principle is still the same. You are going to do it step by step first and then find the final formula. So if I go from x here, any number, and I use the rule of function f, then its image, the partner of x, or the image of x to be precise, should be itself times 2 plus 5. So according to function f, the image of x should be then 2x plus 5, right? Okay, so now this new expression, it's not a value because we don't know what the value of x is. We just want something in general. So this new expression now, I am going to use and apply function g to it. So can I now find g of 2x plus 5? It's the same principle. I'm just going to substitute 2x plus 5 to the x position of the rule of function g. So basically, I am going to substitute 2x plus 5 into x position in the rule of gx. So in that case, this is what I will be doing. I'm going to look for the image of 2x plus 5 with the rule of function g. So basically, I will replace x with 2x plus 5 and then still subtract 3. And if I simplify that, then I will get 2x plus 5 subtract 3. In the end, the new formula will be 2x plus 2. So the new formula, this is the formula that brings you right away from x and right away to the final value here. That will be 2x plus 2. So I think you should be able to understand this. We will look at some more examples in the packet in the next podcast. Good luck.